All right, we can start now. I'm planning to finish lectures today, and on Friday, I'm planning to do a review for the final exam. Today you have midterm 2 at 7:30 online. And I have office hours today from 2:30 to 4:30. You can either come here or you can connect through Zoom. Bugün ofis saatimiz var 2:30-4:30 arası. Zoom'dan da bağlanabilirsiniz. Ofise de gelebilirsiniz isterseniz. Sorunuz varsa. Cuma günü de review yapacağız. Eğer bugün bitirebilirsek konuları. Do you have any question before we start? Var mı sorunuz?
Hocam bugünkü sınav kaç dakika olacak?
Sınav yarımşar saat 2 session halinde, yani 1 saat olacak toplam. Arada bir 10 dakika olacak.
Tamamdır, teşekkür ederim.
Peki. All right, let's start now. So this is the last section, 10.5, heat equation, heat conduction in a rod. Well, so suppose we have a uniform rod of length L. So suppose that we have a rod of length L, okay, and by u xt, it's a function of two variables. Now we do the partial differential equations, okay? So we have two variables, and we will write an equation involving partial derivatives. So by this, well, let's start with the function first. Let's this here, our function u xt denote the temperature of a point x on the rod at time t, okay? And we will assume also that u0t is equal to u lt is equal to t equal to 0 for all time t. That means the temperature is constant. It is equal to 0 at both end points, okay? So that is we assume that the temperature is 0 at both ends of the rod. So let's say this is our rod like this, okay? Here the temperature, well, this is here the 0 point, this is the point L here, okay? This has length L, and at this point the temperature u0t is always 0 for all t, and at this point ult is 0. First coordinate denotes the location, and the second coordinate denotes the time, okay? And at any point, let's say x here, ux T at this point denotes the temperature at this point X and time T. Well, then the heat equation is the following. I will not go to detail, but we can write an equation to find the temperature at the point X and time T, the heat equation. It's given by U sub T, the partial derivative of U with respect to T is equal to some constant alpha squared times U sub XX, the second partial derivative with respect to X. And well, it's a constant coefficient second order linear PDE. Okay, so this is a constant coefficient second order because we differentiate twice with respect to X. Linear because we don't have mixed terms, okay. PD. Well, here alpha is a constant, where alpha is a constant. It depends on the material of the rod. It will be given anyway. Well, here is the goal to find, to solve this equation with some initial conditions. The initial conditions are well, these are as we just mentioned, at both ends the temperature is 0. They're both 0, okay. And we have one more initial. This says basically, well, these are called maybe, let's say, boundary conditions. Two boundary conditions. Boundary because we talk about the endpoints, okay? So these are boundary points. And we have one more condition. This is uxt x0 is equal to f of x. This is the initial condition which describes the initial temperature at any point, okay? Let's say this f of x. F is an arbitrary function, which will be given in the question as well in examples. So this represents maybe, let's say here, initial condition describing initial temperature, but that means T is equal to 0 at any point of the rod. Okay, so the equation is this here, and the initial conditions are given here, two initial conditions, and with these initial conditions we will solve this equation. Well, there are several steps to solve this sort of equation. To solve heat equation, First, we will first solve this one. Okay, first find all solutions to, we will ignore the last initial condition, second initial condition first, and we will solve this one. U sub t is equal to alpha square u sub xx, and this initial condition, the first one only, is equal to u lt is equal to 0. And here we use the idea of separation of variables. We'll talk about this. Okay, we use separation of variables. This basically reduces the problem into an ordinary differential equation. It's a PDE, right? This is a partial differential equation, and using separation of variables, this will be a problem in one variable. Okay, and the second, so there are going to be many solutions in one, and we will choose the one which satisfies the second initial condition. Okay. So among the solutions, in part 1, find the one which satisfies ux0 is equal to f of x, the second initial condition. And to do that, we will use Fourier series. Okay, use Fourier series. Remember, last time we talked about Fourier series, and we know how to find the Fourier series of a function, and using the idea of this, we will find the solution of this equation. Okay, so let's talk about the separation of variables first. Any question so far?
Hocam benim bir sorum vardı.
Tabii.
Burada condition'da mesela u x'de ama t'si sıfırda
Kübra, seni duyamıyorum. Çok
bu
kesin.
f sayı değil mi? Yani böyle bir fonksiyon.
fx'i mi
Yani
diyorsun?
böyle, evet.
Fx bir fonksiyon.
Evet.
Yani işte sinüs x olabilir, kosinüs x olabilir, x kare olabilir, bir fonksiyon.
Yani bu Rodin sıcaklığı initial sıcaklığını bir fonksiyonla tanımlanıyor.
Evet, bir fonksiyon tanımlıyoruz. Çünkü sabit olmak zorunda değil. Her noktada farklı bir sıcaklık olabilir.
Doğru, her noktada farklı bir sıcaklık.
Tamam. Ama sabit de olabilir. Yani o zaman daha kolay çözeriz.
Tamam.
Hı.
Tamam hocam, teşekkürler.
Tamam. So what's the separation of variables? Well, so we assume that the solution is in the form uxt is equal to x. Well, here x is a function, okay, of small x, let's say, times t is another function of time. The first one is a function of the location, the second one is a function of the time, and we write this two separate functions. That's why we call it separation of variables. Of course, the solution may be in different forms as well. Here we look at the solution in this form, and it works for some reason. I will not go into details, but This is what we do, okay? So, well, what is the equation? The equation was, remember, it was this one. U sub t is equal to alpha squared times u sub xx. So let me write here again. The equation was u sub x is equal to alpha squared times u sub t, u sub t u sub xx. This implies, when you use here this form here, what is u sub t? U sub t is basically it's, you differentiate with respect to t. So x is a constant for us now. It's x of x times t prime t, right? This is u sub t. This is equal to, right, this is here, u sub t. It's equal to what? Alpha squared times u sub xx. Now, t is a constant for us, and we differentiate with respect to x. So it's going to be x, our function, double prime of x times t of t. Now, this part is basically alpha squared u sub xx. Okay. Well, now we have this blue equation, and we can write this. We can take all the terms with x and t on different sides. So it becomes like this: t prime t over t of t. Okay, t prime over t basically is, maybe let's also take alpha squared here. Not very important, but let's write it like this, is equal to, on the right hand side, we will have x double prime x, the function, over the function x. Okay. Well, here let's analyze this equation. The first one, on the left hand side, we have a function of t only, right? And it's, this is independent of x. It doesn't depend on x, right? And the second one here, this one, well, this is independent of what? Independent of t. So this tells you basically the left-hand side, since it is equal to the right-hand side, left-hand side is both independent of x and t. Similarly, right-hand side is independent of x and t, right? Yani sol taraf x'ten bağımsız ama sağ tarafta t'den bağımsız olduğu için, sağ tarafta sol tarafa eşit olduğu için, o zaman sol taraf hem x'ten hem de t'den bağımsız. O zaman neye eşit olmalı bu? Bir fonksiyon hem x'e hem t'ye bağlı değilse sabit olacak, değil mi? So this implies the whole thing is independent of x and t, thus it is constant. So let's say this is equal to some constant. This constant, we will call it lambda, minus lambda for some reason. We put minus sign here to make the computations easier. Okay, it's a constant. So this is minus lambda. Well, there is one question. Let me see. How you open the equation? Okay, let's go over this again. How we open this equation? We start with this form of the function. Okay, the function depends on x and t, so we write this as a function of x and t, two separate functions. Okay, and then we had this equation u sub t, derivative of u with respect to t. When you take the derivative of t, u with respect to t, x is a constant, okay, and differentiate with respect to t. So x is a constant means this will stay same, and we differentiate this one only, okay. Take the derivative of t, so you get this one. The second part, we differentiate with respect to x, so t is a constant for us, and we differentiate twice with respect to x, and we get this. Okay, good.
Hocam ben de bir soru sorabilir miyim?
Evet.
Burada şimdi U, X'te temperature tanımlıyor.
Evet.
Bunun heat equation'da T'ye göre türevi alfa square işte X'e göre türeviyle iki kere çarpımı.
Evet.
Yani
denklemin nereden geldiği çok bariz.
Equation olarak bunu bilmemiz gerekiyor. Bir de
bu tabii bu formu bilmemiz gerekiyor. Evet,
sanırım da hocam. Yani bu iki tane separation of solution kısmını ve işte UT'nin alfa square zaten bilmezsek nasıl çözeceğiz? Dondunuz sanırım. Size benim internetim kötü.
Sesin çok net gelmedi Kübra ama yani
evet.
bu denklemi...
Hocam siz de donuyorsunuz.
Ben de mi donuyorum? Tamam.
Arada çünkü bence benim internetimden demek ki. Ben böyle sesimde gitmiyorsam...
Ya burada da internet çok iyi değil. Benden de kaynaklanıyor olabilir. Bu denklemi evet, bu denklem heat equation. Bunu bileceğiz, bu formu. Yani şu formu bileceğiz, evet.
Ve yukarıdakinin de oradaki beyazın da bu formatta olduğunu yani
evet,
büyük
yani şimdi aslında şöyle bir şey var. PD'yi çözmek kolay
olduğunu da bilmemiz gerekiyor.
Evet, PD'yi çözmek çok kolay bir şey değil. Yani it's not easy to solve partial differential equations, but if you assume that the solution in some certain forms, then you can try to find the solution. Here we assume that the solution is in this form. Okay, assuming this, we can find a solution. And this is the trick. Okay.
Tamam hocam. Teşekkür.
All right. Let's now see what we get from this. So lambda is here as a constant on the right hand side. We have two equations. The first one is the following. The first one is t prime t plus lambda alpha square t of t is equal to 0. This follows from here, this one with lambda, okay? And the second equation, is, if we use the second one, lambda with x double prime, so it's going to be x double prime plus lambda x is equal to 0. We have two equations and we will derive a solution from this, okay? Now we will deal with this too. All right. Well, what else we have? The initial conditions, remember? The initial conditions are this. u 0t, the initial condition was this, right? U 0t is equal to 0, and the other one is u lt. We had one more initial condition, but we will deal with that later using Fourier series, remember, in the second step. So we will look at these initial conditions. That means what? That means basically u is in this form, x of t, x of 0 times t of t, right? And here x of L times t of t. Well, this implies that since the first one, let's look at the first one, since the product is 0, one of them must be 0. But if t of t is 0, then we have the trivial solution. We ignore the trivial solution because it will not satisfy the second initial condition most of the time. So that means this here must be 0, right? In order this product to be 0. So it implies that x 0 is equal to 0. And from this, similar, x of L is equal to 0. So at both endpoints, the function capital X is equal to 0. Now, let's work with this one first, since we have the initial conditions with this one. So we have what? The 2 becomes basically the following: x double prime x plus lambda times x is equal to 0 with initial conditions, the following: x of 0 is equal to x of L is equal to 0. Okay, well, this is an ordinary differential equation, right? It's a 2-point boundary value problem. 2-point boundary value problem. Remember, we discussed this last time. It's an ordinary differential equation because we have only one variable, x. Buraya kadar var mı sorunuz? Any questions so far? Thank you. All right, let's try to solve this equation. To solve this, we need to write the characteristic equation. The characteristic equation. Well, it is basically lambda square or r square. Let's say lambda is used for constant, r square plus lambda times r is equal to so lambda times, not, it's lambda only, right? There's no r. R squared plus lambda is equal to 0. It's a homogeneous second order equation, and we can easily solve it. Well, of course, the solution depends on lambda, because if lambda is negative, here, for instance, we have 2 real roots. If lambda is positive, then we have complex roots. So let's discuss these cases in three cases. Okay, so case 1 here. In the first case, we assume that lambda is negative. Lambda is negative. We don't know what lambda is, so let's say lambda is negative in the first case. Well, lambda is negative, so say, for instance, for simplicity again, lambda is equal to it's a negative number, so you can write any negative number like this, minus k squared, because k, for any k squared is positive, minus k squared will be negative, okay? For some k real, okay? In that case, what is the solution of 2? So the general solution to 2, well, the roots are what? The roots are r is equal to plus minus k, which implies x of our function, the solution, is going to be c1 times e to the kx plus c2 times e to the minus kx, right? So this is the general solution without the initial conditions, boundary conditions. So let's put the boundary conditions. X of 0. X of 0 is what? X of 0 is e to the 0 is 1, so c1 plus c2, and it's equal to 0. Well, x of L is what? C1 times e to the KL plus C2 times e to the minus KL is equal to 0. So from this, let's try to find C1 and C2. This implies C1, C2 is equal to minus C1. So let's put this back in here. We can take C1 parentheses. So it's going to be e to the KL. Now C2 is minus C1, so minus e to the minus KL is equal to 0. But this is non-zero because K and minus K are different, right? So this is non-zero. So this implies C1 must be 0. But if C1 is 0, C2 is also 0 because C2 is minus C1. So C2 is also 0. Well, this tells you basically it must be 0. But this is a trivial solution. And we are not interested in trivial solutions because later we will put some initial conditions, second initial conditions, which is non-trivial. So this implies there is no non-trivial solution in this case. No non-trivial solution when lambda is less than 0. So in this case, we don't have any non-trivial solution and we can ignore this case, okay? Any question so far? Çünkü x eğer 0 olursa o zaman u'yu hatırlarsak u da 0 olacak. If x is 0, then u is 0. Well, if u is 0 and f is non-zero, then there is no solution, right? Okay, we can ignore this case and move to the second case. The second case is lambda is equal to 0. So this is case 2 now. Lambda is equal to 0. This constant in the equation, it's equal to 0.
Hocam en üzeri grafiklerini çizme şansınız var mı?
Ee,
Ben orayı
bir dakika.
görünce böyle diyebilirim yani.
Ha,
Evet yani böyle
grafikle çizdin mi?
evet mesela onlar sıfıra hani bunlar birbirine eşit değiller falan. Çünkü gerçi e üzeri k'de böyle 1 bölü e.
Şu bu sıfır olamaz çünkü bu sıfır olması e üzeri kl eşittir e üzeri eksi kl olacak. O zaman k eşittir sıfır olabilir ancak. K sıfır olamaz çünkü lambdayı burada bir soru daha var. K sıfır olabilir mi? K cannot be zero because if k is equal to zero then lambda is also zero but we assume that lambda is negative. Okay? So k cannot be zero. Açıklayıcı oldu mu Kübra?
Oldu
Tamam.
hocam.
Okay, the second case now, lambda is equal to 0. In that case, let's look at the characteristic equation. In this case, r square is equal to 0. So we have the characteristic equation. R square is equal to 0. This implies that we have two roots, R1 and R2, which are both 0. These are repeated roots. Repeated roots. So what is the solution in this case? The general solution of this function. Well, again, we will have x of x, sorry. X to the e to the 0 x, which is e to the 0 is 1. So we have 1 and 1, but it's repeated. So you multiply, you have repeated roots. Remember, you multiply the solution with x, right? So we have here two solutions, 1 and 1 times x, okay? Or maybe let's write it like this. Two solutions like this, e to the 0x, and from this, x times e to the 0x. E to the 0x is 1. And this is x. So the combination of this two, c1 plus c2x. This is the general solution. And let's put the initial conditions. What is x of 0? X of 0 is, it was 0, and it's c1. So c1 must be 0, and x of L is also 0. Well, c1 is 0, so this is c2 times L. Since L is the length of the rod, it is non-zero. That means c2 must be 0 değil mi? L uzunluk olduğu için pozitif. Dolayısıyla C2 sıfır oluyor. Yine o zaman, again we have the trivial solution. Only we have trivial solution. So this implies here x of x is identically 0. Again, no non-trivial solution when lambda is equal to 0. In this case, again, we don't have any solution, non-trivial solution, and we can ignore this case as well. Any question so far? Now we move to the last case when lambda is, well, we assume that lambda is negative, lambda is 0, so lambda is positive, right? So this is case 3. Now we have lambda is positive. Now we will have some solutions, you will see. So when lambda is positive, say lambda is equal to, for instance, k square. K square is always positive. This implies that the characteristic equation r square is equal to minus k square. Okay, so we have two solutions, r1 and 2. which are plus minus k times I, complex roots, right? We have complex roots in this case. For complex roots, we choose one of those, and from this we have the solution e to the k I x, okay, xki. Well, two real roots from this, cosine kx and sine kx, right? We take the real part and imaginary part of this complex solution, and we get two real solutions from one complex solution. Let's write the general solution. So the general solution is in this case, we have x of x is equal to c1 cosine kx plus c2 sine kx. Let's put the initial values. Initial values are x of 0, it was equal to 0. When you plug x is equal to 0, you will get cosine 0 is 1. So c1 times 1. Sine 0 is 0. So we get that c1 must be 0. Okay. What about c2? So to find that out, we will put this other initial condition. Now c1 is 0, so it's going to be c2 times sine kx, sorry, kl. We put x is equal to l, okay? Now we have many solutions from this. We have we do not want here the trivial solution. C2 is 0, gives C2, when C2 is equal to 0, we have the trivial solution, but we don't want this. Here, this is equal to 0 means this is equal to 0, let's say. Sine KL is equal to 0 if what? KL is equal to, when is sine 0? Right, 0, pi, 2 pi, 3 pi, so n pi basically, right? N times pi, any multiple of pi. Here n is any integer, okay? It's any integer, positive or negative. Well, this implies that, what is k, by the way? Let's go back. So lambda is equal to k squared. So lambda is equal to k squared, right? It was this. So this says what? K is equal to n pi over L. So let's put this back in here. So k squared is n squared pi squared over L squared, okay? So we get this lambda. Here n can be any integer. When lambda is equal to that number, we have many solutions, okay? Depending on n. Here, maybe I should say n is any integer. Okay, there's one question, why here C2 is not equal to 0? If C2 is also 0, C1 is 0, C2 is 0, we get a trivial solution again. But we don't want trivial solution, okay? Trivial solution means the solution will be 0, okay? So we look at non-trivial solutions, and non-trivial solutions will show up when lambda is equal to like this. All right, good. Well, you can consider positive n's because we have n squared. When n is negative, you will get the same, right? So let's see what we get from this. So we consider now, we return to remember originally we had two equations, number 2 here, number 1. So we return to the first one now and solve it with this lambda, right? Because when lambda is equal to that number, we have non-trivial solution for number 2 here. So we will choose lambda like this and solve the first one, okay? Return to number 1. So remember number 1 was this t prime t plus lambda t, but lambda is now alpha square lambda, right? Let's see what it was. Lambda times alpha square. So lambda times alpha square, it becomes n square pi square. This is lambda times alpha square times t of t is equal to 0. Here this is lambda, okay? Now we try to solve this one. By the way, I forgot to say the solution coming from the second one. Maybe let's write this first here before we go into the second step here. Okay, let's first continue with this part. So we get this lambda, and what is the solution in this case? C1 is equal to 0. C2 is like this. So the solutions are to number 2. These are x. C1 was 0. C2 is an arbitrary number. It can be any number you take it. So C2 times sine kx, and k is sine. What is k here? N pi over Lx, okay? This solution depends on n, so for any n, we have different solution. So let's put here n, okay? We have many solutions like this for any n, like 1, 2, 3, and so on. Now we return to this one and solve it. This part is easy now because we know what lambda is. Lambda is same both for 1 and 2. So we find the lambda in the second equation, and we put it in the first equation, and now we solve it.
Hocam, why we write L instead of L square?
Maybe, yeah, it's a mistake. Sorry. Thanks for this. It's L square, right? So we do here, it's a separable equation. So you can write it like this, t prime t over t of t. You can take this constant to the right hand side. It's going to be minus n squared pi squared alpha square over L square. Okay. Now this is an easy equation to solve it, right? You can integrate both sides. Integrate both sides. Okay. So you will get basically from this ln t, natural log of t, when you integrate this. On the right hand side, you will have minus n square pi square alpha square over L. It's a constant times t. We integrate with respect to t. So this implies simply we get, take the exponential now, t is equal to e to the minus n square pi square alpha square over L square times t. Well, again, the solution depends on n, right? For each n, we have different solution. Let's put here tn, t sub n. Okay, so we get solution for t. We already had solution for x. Where is it? Here. And we combine the solutions to get the solution of u. Remember, u is here at the beginning. U was, where is it? X times t. So we multiply this 2 and we get the solution. This implies u xt is equal to, remember it was x of x times t of t. Okay, so we just find out here it, x is what was it? Sine. You can ignore the constant here. Sine n pi over Lx. Sine n pi over Lx times e to the minus n square pi square alpha square over L square times t. Well, again, the solution depends on n, so for each n, we get a different solution for all n from 1, 2, 3, and so on. Well, the nice thing is if you have two solutions, then their combination is also a solution. This is a principle of superposition. So we take all combinations of these solutions to get the general solution. Okay, so the general solution to heat equation, it's the infinite combination of linear combination of u and t. So it's going to be u xt is equal to the sum of, you multiply with some constant cn, un t, n is from 1 to infinity. Here cn is an arbitrary constant for any n. Okay. Well, of course, the solution depends on cn. If you choose different constant, you will get different solutions. So what you do in the second step, remember, you will find the one which satisfies the second initial condition. So the second step here. Remember, the second initial condition was this: u x0 is, this is equal to f of x, right? F is a function given in the question. So what you do is you plug for t is equal to 0, and it becomes what? It becomes the following. When t is equal to 0, we get what? We get e to the 0. E to the 0 is 1, right here. When t is equal to 0, e to the 0 is 1, so you will end up with only sine n pi x over L. Here, n is from 1 to infinity. Okay, there's one question here. Okay, we are not doing review for midterm. We will do review for final exam on Friday, not for the midterm, but I have office hour today. If you have any question, you can come to my office hours from 2:30 to 4:30. There is the U right hand side. Of general solution in terms of x.
Hocam toplam sembolünün içindeki UNT'yi de olabilir. Ben de onu soracaktım. Mesela CN,
UN, XT, of course, yes.
Tamam, teşekkürler hocam. Yani ben onu soracaktım da hocam da onu.
Aynı şeyi sormuş arkadaş herhalde, tamam. X, this should be XT, sorry, with a type. Okay. Now we will find the one which satisfies the second initial condition. Well, this is basically, remember, there is Cn here, sorry, Cn. So you will find Cn here. How do you find Cn here? Cn is the Fourier sine coefficient of f, right? So this is here. Cn is the Fourier sine coefficient of f. Remember the Fourier sine coefficient by the Euler's Fourier formula. So Cn is equal to 2 over L integral from 0 to L, right? You write the Fourier coefficient, f of x times sine n pi x over L dx. Okay, so we get the general solution by this. Here is the general solution. Maybe not this one, sorry. This is better. Okay, like this. Okay, we no, not this. Sorry, the first one was right. This one. So this is the general solution, and we put the initial condition, and we find Cn here. So Cn, this is dx. So to find Cn here, okay, we use this, and we get the solution. Okay, we will do one example, concrete example with this, and we will be done. Any question so far? Var mı soru arkadaşlar buraya kadar?
Hocam şimdi burada kökleri bulurken yani bu u x t'nin x x t t şeklindeki solution'ını hani boundary'ler 0 ve 0 0 işte başında ve sonunda 0 olacak şekilde bulduk. Evet. Bu boundary'ler hiç mesela sınavda da değişmez değil mi? Mesela sonundaki
Yok.
Sıcaklık 50 falan olmaz. Yani yok, o zaman
o zaman çözüm zor olur. Yani bu bizim standart şeyimiz bu.
O zaman bu standartta aslında bir Seat equation'ın böyle çözümünü de biliyoruz. Hani kimi soruları böyle çözeriz ya. Böyle
evet, doğru. Yani aslında çözümün formunu biliyorsun, doğru. Yani bu kadar işlem yapmana gerek yok. Doğru diyorsun. Yani
değil mi? Şu anda siz aslında çözümü, yani biz bunu sınavda kullanabiliriz. Bu son hali.
Doğru.
Tamam hocam, teşekkür ederim.
Tamam. Zaten örnekte de öyle yapacağız. Tekrar uzun bunu yapmayacağız.
Tamam hocam, teşekkürler.
That's right. So, well, this form basically gives the solution in this sort of problem. So you don't need to follow all the steps to get the solution at the end. Peki bir ara verelim. Kaç geçiyor? 43. So let's meet at 12. Okay, so we will be done in, I guess, 30 minutes with a simple example. So let's meet at 12 to complete this lecture. Merhaba arkadaşlar. Welcome back. So let's continue with an example. Any question before we continue? Okay, let's do this example. So the question is find the temperature UXT at any time in a metal rod of 50 centimeters long which has initial uniform temperature which has initial uniform temperature (20°C) throughout and whose ends are maintained at 0°C for all t. So let's write the equation to model this problem. The differential equation is given by u sub t is equal to alpha squared times u sub xx. We don't know what alpha is. Alpha is a constant, okay? Depends on the material here, the metal rod. And L is equal to 50 centimeter. This is the length of the rod. And it says the initial temperature is 20°C, which is independent of x. So that means basically f of x is always 20, okay? It's a constant function. And the initial boundary values are here. Endpoints, at the endpoints, U50 T, the temperature is always 0 because it says ends are maintained at 0°C, and Ux0, the initial temperature is 20, right? F of x. For all x between 0 and 50. All right, so we solve this equation. we already find a formula in the previous lecture, right? So by previous result, let's get this. Okay, so by previous result, the solution is given by this, right? U of xt is the sum of Cn e to the minus n square pi square alpha square over L square, but L is 50, so it's 50 square. Okay. Times sine, there is t here, right? T, okay. Times sine n pi x over L. L is 50. We need to find Cn here. And remember, Cn was the Fourier sine coefficients. It's given by 2 over L, which is 50, from 0 to 50. Okay. F of x times sine n pi x over L. So f of x is 20 times sine n pi x over L. Okay, dx. We compute this integral. It's a simple integration. Take this 20 out, 40 over 50. You integrate sine function, so it's going to be 50 over n pi cosine n pi x over 50. You plug x is equal to 0 and 50. Okay. Well, we get what? There's cancellation here. So it's going to be 40 over 50. Oh no, 40 over n pi. You plug n is x is equal to 50, so it's going to be cosine n pi minus you plug here 0, so it's 1. Okay, well, we can simplify this numbers. Well, if, for instance, n is equal to 0, cosine 0 is 1, 1 minus 1, 0. When n is equal to 2, again, it is 1 minus 1. So when n is even, this number will be 0, okay? So 0 when n is even. If n is odd, it's going to be cosine n pi will be minus 1. So it's going to be minus 2, minus 1, minus 1, minus 2. So minus 80 over n pi if n is odd, then we get, oh, I did something wrong, right? This integration here with negative sign, it should be negative sign here, okay? There is -1 here, okay? So it's gonna be like this with minus sign here, okay? If n is odd, it's going to be -2, -2 times -40, 80 over n pi. Okay. So n is odd means n is like 2k plus 1, for instance. Okay. Any question so far? Okay, now let's combine this. So this implies basically u xt is equal to the sum Cn. Cn is, if n is odd, it's 80 over n pi. So otherwise it is 0. So we have only odd terms here. So it's going to be 80 over, instead of n pi, I will write 2k plus 1 pi. When k is any number, you will get odd numbers for 2k plus 1, right? So k is from 0 to infinity. This is Cn, okay. Cn part. Now let's continue with the rest. E to the minus n square minus 2k plus 1 square pi square alpha square over 50 square is 2,500, okay, t, okay, times the sine part, sine, what happened to k? Okay, okay, 2k plus 1, good. Sine n is 2k plus 1, 2k plus 1, this is n, pi x over 50. Okay. So this.
Sorry, can I say something? If I'm not mistaken, it should be alpha square.
Probably, yeah. It should be alpha square. Yes. Okay, thanks. Thanks for this. All right, so this is the solution of the heat equation with this initial boundary value. Okay, boundary values. Okay, good enough. Any question with this? Var mı soru bununla ilgili arkadaşlar? Peki, o zaman burada bitirebiliriz. So we can stop here. That was the end of the course lecture for this semester. As I said, we will do a review on Friday morning in the lecture hours. You can bring your own problems, or I will solve some problems for the review. And today you have a midterm at 7:30, and I will have an office hour from 2:30 to 4:30. You can either come here or connect through Zoom if you have any question. Okay.
Her şey için teşekkürler hocam.
Tamam, ben de teşekkür ederim. Güzel bir dönem oldu. Katılımınız için ben teşekkür ederim. Var mı söyleyeceğiniz, soracağınız bir şey? Okey, tamam. Görüşürüz o zaman. Yine sorunuz olursa her zaman bana ulaşabilirsiniz. Bol şanslar. Görüşmek üzere.
İyi günler hocam.
İyi günler.